a screwdriver again?
No.
Okay, that's good. The thing that might help you is increasing this so you can see.
So the circuit works by changing the value here on this potentiometer, which attenuates the PWM signal that controls this motor here. Well, rather than attenuating, it adjusts the duty cycle. And by adjusting the duty cycle, that tells the motor how to orient itself. If we had a constant duty cycle, it would not move. So we have to use potentiometer in place of one of the resistors on our circuit to change the duty cycle. We have it set at 1 hertz input signal with 9 volts as the main power for the timer. We have 6 volts set on the CON pin, and if we wanted to develop this another way, we could have the input signal to this 555 actually be another 555, outputting a constant 1 hertz signal, and then we could have that battery operated. Here's the circuit. Also, one more thing that could be done in a final prototype version would be to replace the potentiometer with a potentiometer that has a knob. There are a few around in the lab, but they're for lower values of potentiometer than we needed for our circuit. But with a knob, you'd just be able to twist it close and shut with your hands rather than having to use a screwdriver. Also, the design of this circuit differs from what I planned in the abstract because it was necessary to use a potentiometer to adjust the duty cycle coming out of the 555 timer output. This required putting in a potentiometer that requires human intervention instead of doing it on a regular interval. Also, I just wanted to clarify that if we had a constant duty cycle, it wouldn't necessarily not move, but it would simply move to the position that would correspond to that orientation for the duty cycle on the motor, and then it would not move after that. So we have to have the potentiometer there to adjust the duty cycle to move it back and forth.